morning, students. Today we are going to learn about factor theorem and factorization of a polynomial using factor theorem. So here we go. See, you know 3 is a factor of 42. You know that 3 is a factor of 42. There are other factors of 42 also, like 1, 2, 3, 6, 7, 14, 21. All these are the factors of 42. Now why are these the factors of 42? Why is 3 is the factor of 42? That is the main question. I repeat, we know that 1, 2, 3, 4, 6, 7, 14, 21, and 42 itself. All these are the factors of 42. Now the question arises, why are these the factors of 42? So means let us take one of them, 3. Why is 3 a factor of 42? Let us try to answer this question. For 3 is a factor of 42 because 3 divides 42. Because 42 is divisible by 3. Because when we divide 42 by 3, okay, when we divide 42 by 3, remainder comes out to be 0. Remainder comes out to be 0. This is the reason. That means when we are writing the Euclid's algorithm, dividend is equal to divisor multiply dividend quotient multiplied by the divisor plus remainder. Alright, so then we get it like this. So what is the main point? That 3 is a factor of 42 because when we divide 42 by 3, remainder comes out to be 0. Okay, so that means if remainder is 0, that means if remainder is 0, then divisor is a factor of dividend. You know, when remainder is 0, then divisor is a factor of dividend. That is what we have learnt. So final time I am saying 42 is a factor of 3 is a factor of 42 because remainder is 0. So when remainder is 0, then this divisor is a factor of dividend. Now in case of polynomials, what is the case of polynomials? So that means if we write this in case of polynomials, okay, so what do you know? We have learnt in the previous section that if we will divide x by a, if we will divide px with x by a, then the remainder will be equal to p of a. Similarly, if we divide px by x plus a, then the remainder will be p of minus a. This is what we learnt in the previous section. And now, what does this mean? This means that remainder is 0, then 3 is a factor of 42. This means that if this remainder PA or remainder P of minus A, they are coming, if PA is coming equal to 0, remainder is coming equal to 0, then x minus A is a factor of PX. If P of minus A is coming equal to 0, remainder is coming equal to 0, then x plus A is a factor of Px. So friends, this takes to our factor theorem. So factor theorem says x minus a is a factor of polynomial px if remainder is equal to pa is equal to 0. So this is the definition, this is the statement of factor theorem. Note it down, then note down this question also. Now let us try to solve this question. So what does the question say? You find out, you have to find it out whether x plus 5 is a factor of px or not. How will you find? You will straight away find the remainder. If remainder is coming 0, then this is a factor. If remainder is not coming equal to 0, then this is not a factor. So x plus 5 will be a factor of px if remainder is coming out to be 0. So let us find the remainder. Remainder is equal to p of, see this is x plus 5, so remainder will be p of minus 5. Do you remember that? If this is plus, then this is minus. If here it is minus, then here it will be plus. Do you remember this? How does that come? When we are putting x plus 5 equal to 0, then we are finding the value of x is minus 5. That value we are putting here. So the remainder is p is equal to p of minus 5. So let us find the remainder. So it is x cube means minus 5 cube plus x square means minus 5 square plus 3x means 3 of x plus 115. I repeat, x cube minus 5 cube. So I repeat, x cube means minus 5 cube plus x square means minus 5 square plus 3x plus 3x plus 115. So now this is minus 5 cube minus 125 minus 5 square plus 25 plus minus minus 15 plus 115. So plus numbers are 25 and 115. This gives you plus 140. Minus numbers are 125 and 15. So this also gives you 40. So remainder is coming out to be 0. Remainder is 0. Therefore, x plus 5 is a factor of px. This is how we have to solve. If this is not equal to 0, we will write on is not equal to 0, and here we will write on is not a factor of px. When this is not coming out equal to 0, we will write on is not equal to 0. Where we will write? We will write here is not equal to 0, and here we will write this is not a factor of px. Right? So students, this we have learned, and on the basis of this you have to solve question number 1 and 2 of the exercise 2.4. right? If any problem you face, you will tell me and I'll help you to solve that. So if you have any problem, I'll help you to solve that problem. So let us now let us come to the next type. Here what are you seeing? The problem is find the value of k if x minus 3 is a factor of k square x cube minus kx square plus 3kx minus k. Okay, how to do this? We have to find the value of k. We have to find the value of k, and we know that x minus 3 is a factor of this. So students, first of all we have to name this. Because there is no name of the polynomial, So let us name this. Let px is equal to kx square x cube minus kx square plus 3kx minus k. Now, since x minus 3 is a factor of it, is a factor of px, therefore remainder is 0. Remainder, what is the remainder? Remainder is p minus 3. Sorry, not 3, minus, plus. Because here it is minus, so here it will be plus. This is 0. Remainder is 0. Now, p3, we are going to find out p3. We are substituting x as 3 in px. Here we are having 3. So here also 3, here also 3, here also 3. So remainder is equal to this remainder, okay, this remainder is equal to k square 3 cube, k square 3 cube, k square 3 cube plus 3 ना, 3 cube. if there is minus तो हम माइनस रखते, तो यहाँ माइनस लिखते. अगर यहाँ माइनस होता और यहाँ प्लस होता तो here it is minus, so here it is plus, तो यहाँ पे हम इसकी जगह पे प्लस रख रहे हैं. so now minus kx square minus kx square plus 3kx plus 3kx minus k is equal to 0. See students, I managed to have equal to under equal to. This is how you need to write. ऐसे लिखना है पूरा, equal to under equal to, and here there is the sign. This implies it is important. Now we are solving this further. 3 cube 27, 27 k cube, 27 k cube minus 9k. Again here it is 9k minus k is equal to 0. So this goes off with this, 9k goes off with 9 है ना. So we are left with 27 k cube minus k is equal to 0, and from here we can find the value of k. Students, I have taken a difficult problem. The problems in your exercise are simple problems. There you will find the value of k easily. Here it has again come out to be a little tough equation. Okay, so I have taken a little tough question. Questions in your exercise are simple. Based on this, you will solve question number 3 of your exercise. So now how can I find the value of k from here? So my ways are, I'll take k as common. So here inside we are taking not k common. This is 3k cube okay. So I'll take k common, and then I'm left with. So students, I have done a mistake. Here you see it was k square. Okay, it was k square here. So here by mistake I have written cube, so it is square. So it is square. Again it is square. Okay, now I have taken k common. So here I'm trying to find out the value of k. I'm taking k common, so I'm left with 27k minus 1 is equal to 0. So either k is equal to 0, either this is equal to 0 or this is equal to 0, or 27k minus 1 is equal to 0. So this implies k is equal to 0, or here you see minus 1 goes that side, becomes plus 1. 27 goes that side, becomes over 27. So k is equal to 27. So finally I missed this, I think of it was out of the camera. So I repeat here, 27k minus 0 is equal 27 minus 1 is equal to 0. So minus 1 becomes 1. Okay, minus 1 becomes plus 1. 27 becomes over 27. So k is equal to 1 over 27. So finally we are getting two values of k here. One is 0 and one is 1 over 27. Okay, and we can write here or in place of comma we can write here or. Students, in all your questions in the exercise you will get only one value of k. Your questions are simple. So now based on this you will solve question number 3 of your exercise. Okay, question number 3 of your exercise. So I'll just show the question in one lot. You can have the screenshot of it and then you can proceed further, right? So students, that was all for today. You're going to solve question 1, 2 and 3 and you're going to send me the solutions by 12 o'clock. Try to send me the solutions as soon as possible. Thank you.